All right, today we're diving into some really cool research. It's all about teaching AI a skill that, honestly, we humans take for granted: how to learn new things on the fly.
I mean, we've all seen the headlines. Modern AI, especially in the field of reinforcement learning, is doing some mind blowing stuff. You've got these AI agents that can master insanely complex games like Go, and not just play them well, but play at a superhuman level that no person can even touch. It's just brilliant.
But here's the catch, the big twist in the story. This incredible AI genius, well, for all its power, it has this one surprising fundamental weakness. It's like this massive intellectual blind spot that really holds it back from being useful in our messy, always changing real world. So that brings us to our first big topic, what I like to call AI's one-track mind. This really gets to the heart of what researchers call the brittleness problem. And this quote just nails the problem perfectly. Think about it. An AI can spend, tens of thousands of games mastering Miss Pac-Man. It becomes an absolute pro, better than any human. But then you ask it to play, I don't know, Space Invaders? It's completely clueless. It knows nothing. You literally have to start from scratch and train a whole new AI. So they're powerful for sure, but they're basically these super brittle one-trick ponies. So it really makes you wonder, right? If these AIs are so brilliant, why can't they adapt? Why can't they just take what they've learned and apply it to a new, even a slightly different situation? The way you and I do all the time. Well, that exact question is what leads us to the solution at the heart of this research. It's an idea called learning to learn, and it's a total shift in how we think about training AI. Okay, so let's break this down. The old way, standard learning, is all about training an AI to solve one specific problem. That's it. But this new approach, meta-learning, it's completely different. Instead of teaching the AI what to learn, you're teaching it how to learn. The whole goal shifts. You're not trying to make a master of one game anymore. You're trying to build a fast learner that can get good at any new game you throw at it. So, how does this actually work? Well, it really boils down to two pretty simple steps. First up is task inference. This is where the AI lands in a new situation and has to figure things out, kind of asking itself, okay, what are the rules here? How does this work? Then, once it's got a handle on the problem, it switches to task solving. It digs into its toolbox of existing skills and figures out, all right, how do I win this thing? And there's a great analogy for this: a house cleaning robot. So imagine a robot that already knows how to do all the chores: mopping, vacuuming, dusting. That's its task-solving skill set. But if you drop it into a brand new house, what's the first thing it has to do? It has to learn the layout, right? Map the rooms, figure out where the sofa is. That's the task inference part. It's not relearning how to clean, it's just learning the new environment so it can apply the skills it already has. Okay, so how does an AI actually pull this off? Like, what's the trick? What's the mechanism inside its brain that lets it summarize a new task so fast? Well, this brings us to a super clever technical idea. You can basically think of it as giving the AI a cheat sheet. So this cheat sheet has a technical name, of course. It's called a context vector. And it's exactly what it sounds like. It's a small piece of the AI's brain that's reserved for one thing: summarizing the key details of the task it's currently on. It's almost like a digital sticky note where the AI jots down, okay, here's what's different about this problem. And you can see it in action right here. In this example, the AI is dealing with a bunch of different wave-like puzzles. Now, each wave is a little different. It has a different height or amplitude and a different starting point, its phase. Instead of getting bogged down in all that complexity, the AI learns to boil it all down to just two simple numbers on its cheat sheet. And by just looking at those two parameters, it instantly knows the exact puzzle it needs to solve. Okay, that's cool for simple math puzzles, but what about the real world? Does this actually hold up? Well, this is where the research gets really interesting, because they start tackling some much, much bigger challenges. They took this core cheat sheet idea and really pushed it to its limits. They started using it to handle some of the messiest problems you can imagine. Like, what do you do when you're uncertain about the task, when you don't have all the info, or when you have to interact with other AIs, or even people? And maybe the biggest one of all, how do you learn when you get almost zero feedback? Yeah, that last one is a really huge challenge in AI. It's called the sparse rewards problem. Just imagine you're an AI and your job is to find a tiny little treasure on a vast mountain. I mean, 99.9% of the time, you're just wandering around getting nothing. No feedback, no rewards. How on earth are you supposed to learn where to go? And honestly, the difference is just dramatic. Look at the standard AI on the left.
It's totally lost, just wandering around with no idea what to do because it's not getting any of those reward signals to guide it. But the meta-learning agent on the right, it's a whole different ballgame. It isn't just blindly searching for the reward, it's actively trying to understand the task itself. This pushes it to explore in a much smarter way, to gather information, and look at that, it finds the goal way, way faster. So, look, this isn't just some abstract experiment. This kind of research is actually pointing toward a future with AI that's way more capable and flexible than what we have today. So, why does any of this matter? Well, because this is a really key step toward the kind of AI we've been dreaming about for decades. We're talking about building general-purpose robots that can walk into a new factory or a new home and just adapt. Or video game bots that can actually learn and adjust to your specific skill level. Or even assistive technology that can truly personalize itself for each user. But we're not quite there yet. There's still one massive hurdle to overcome. See, this learning-to-learn approach works great when the new tasks are at least kind of similar to what the AI has seen before. But what happens when it runs into something totally new? A problem that is completely different from anything it was ever trained on? Well, that problem has a name. It's called distribution shift. And it is one of the single biggest open questions in the entire field of AI right now. Figuring this out, creating an AI that isn't just a fast learner, but it's also tough and resilient when faced with the truly unknown, that is the next grand challenge. And it's the key to making AI genuinely intelligent and reliable.